Okay, here's a video on how to do objective 5.3. You need to know how to do the Pythagorean theorem first. If you need to know how to do the Pythagorean theorem, which is a squared plus b squared equals c squared in a right triangle, then I recommend going to a different online tutorial or the video that I posted, also on Google Classroom, separate from this one. But once you know how to do the Pythagorean theorem, the rest of this kind of falls out of that. They say if the length of AC is 10 meters, what's the length of AB? That's this one. Well. We're trying to find the length of AB. You know, AC is 10 meters. First thing I do is label that on here. But look at these two 45-degree angles. Those are the congruent, making this an isosceles triangle. That's the converse of the isosceles triangle theorem, but you can see this is an isosceles triangle. So this is 10 as well. And so they're asking, what's the length of AB? AB is this length right here. If we're trying to find that length, well, it's going to be a squared plus b squared equals to c squared. Keep in mind that the capital A, capital B, and capital C are different from the lowercase ones found here. That is why I tell you to make sure you don't switch upper and lowercase letters. So this is your A and this is your B, or vice versa. So it's 10 squared plus 10 squared equals c squared. 10 squared is 100, so it's 100 plus 100 equals c squared. In other words, c squared is 200. So the final result, we'll take the square root of 200. Now the result is approximately 14.14. However, I am fine with you writing it as the square root of 200, and in fact, I prefer you do that. But if you do get a clean number, like say square root of 100, if you had gotten that as the answer, just leave that as 10, and not the square root of 10. I know I said that all really fast. Feel free to rewind this to hear what I said again. The result is square root of 200. And I guess it would be meters. M for meters. If AC is 10, what other length must also be 10? Justify your answer, and this is kind of the hard part. The length that has to also be 10, well, I look at this, I'm seeing two congruent triangles. How do I know they're congruent? By angle, side, angle, the triangles are congruent. That's angle, side, angle. So if I can use angle, side, angle to show the triangles are congruent, then that means that all the other matching parts have to be congruent. Well, if AC is 10, I have to look at which one it matches with, which one corresponds to that. And this is really like a flip or a rotation of the other one. So I can rotate it around, and AC is going to match up with ED. Convince yourself of that by flipping it over or by noticing that AC is the one that connects the single to the nothing, and ED also connects the single tick to the nothing. So ED must also be 10. So ED equals 10 since it corresponds to AC. That's about it. If I had said AB was 12, then that would have meant DF would be 12. If I had said angle EDF was 50 degrees, that would mean that angle BAC would also be 50 degrees, and so on and so forth. Every piece of these triangles matches, just in different places. Erase this so we don't get confused and think that's part of the problem later. So ED has to also be 10. Going to level 2, if you're proficient with this, going to the Pythagorean theorem, you can kind of combine these multiple steps together. We say AE equals AD equals AC. So what and AB is 5. I label that on the diagram. AB is 5, BC is 12. And immediately I see a right triangle with legs here and here. So I can use the Pythagorean theorem. So c squared is going to be 5 squared plus 12 squared, or 25 plus 144, which means c squared is 169. If c squared is 169, then c is the square root of 169. 169, which is 13. That means that this length is 13 by the Pythagorean theorem. But look, they told us that AE is the same length as AD, which is the same length as AC. So that means that all three of these are congruent. This one's 13 also. So AE is 13. Done. Just combining it, it's like, hey, here's the Pythagorean theorem. Let's then use it to find it in something else. The 64 degrees is not really necessary at all in this problem. Find x. Whoa. If we need to find x here, here's a little bit of a struggle that people have, is they're like, well, what do I do with all three of these numbers? But you just got to reason as to what am I finding in this case. I see a right triangle. That means I can find its hypotenuse because I have both its legs. So to find its hypotenuse, what do? C squared, and I'll call this one C. Well, that's equal to 20 squared plus 15 squared. So c squared is 400 plus 15 squared is 225. I should have that memorized. So c squared is 625. Well, if c squared is 625, then what is c by itself? It's the square root of that. The square root of 625 is 25. So that means that c is 25. So this length that I'm highlighting in red here, that's 25. Now look at the red triangle. This red triangle is also a right triangle, so I can use the Pythagorean theorem a second time on it. Now that I know this, use it to find x. So we'll do x squared, because that's x instead of c. Well, what is that? That's 18.75 squared plus 25 squared. If I do that all out, 18.75 squared is 351.5625 plus 25 squared, which is 625. And the total of that is 976.5625. Encourage you to use a calculator there. Take the square root of that, because we have x squared here. So x will be the square root of that, which turns out to be 31.25. And that's the answer for x. And I guess it would be centimeters, since they do tell you a unit here. Centimeters. So it's 31.25 centimeters. And that makes sense because it's a little bit longer. Like this is 15, this is 20. It seems to make rough sense that this one will be the longest side in there, 31.25, but not that much longer than it. All right, here's our final problem on level 3. In the diagram, Galen determined that AB is 3/4 the length of BC, and that DC is 1.5 times the length of BC. Oh boy. He also noted that segments AE and AD are congruent. I still don't see anything on here that I can mark until they say congruent. AE and AD are congruent. AE is congruent to AD. Oh, and that already has a mark on it. Excellent. So that means that these two are congruent, and they're also congruent to this one. So all three of the marked sides, AE, AD, and AC, are all congruent. They tell us that AB is 6 meters long in the final structure. So this is going to be 6 meters, M for meters. If that's the case, what's the length of AD? AE. Okay, so how can he figure out the length of AE? Okay, this is another problem where it's like they say find AE, but really that's just going to be the same as finding either of these two. And since I have a right triangle, that leads me to believe that I can use the Pythagorean theorem for this. So I'm going to be looking over here, finding the length of AC, and then AC will be the same length. So we can even start our explanation off with that. AE will be same length as AC. And I can even go a little bit deeper, though you don't always have to, since both equal AD. AE and AC are both equal to AD, so they've got to be equal to each other. That's the transitive property. Let's see if I can find the length of BC somehow. I can find the length of BC. Oh, they say AB is 3/4 the length of BC. AB, you can even write an equation for that. AB is 3/4 of BC. Remember, well, let's solve this for BC. If I want to find BC, what I could do is I can take both sides of the equation and multiply them both by 4/3. Why 4/3? Because 4/3 will cancel out 3/4 when I multiply them. The 4 and the 4 cancel, and the 3 and the 3 cancel. So that means that BC is 4/3 of AB. But we know what AB is, it's 6. So 4/3 of 6. Multiply 6 by 4/3. That's 8. By the way, you can do that by doing 6 times 4 is 24, and then divide that result by 3, which would give you 8. So that means that this length is 8. Question mark length, which is BC, is equal to 8. Write that on here. Then that means I can also find this using the Pythagorean theorem. They say 6 squared plus 8 squared, and that would equal to C squared. Because they do say a squared plus b squared equals c squared. So this is 36 plus 64, which is 100, is equal to c squared, and therefore c is 10, and c being this side. So if AC is 10, that means that AE is 10. So we can say by work below, BC is equal to 8. So by Pythagorean theorem, that's PT, Pythagorean theorem, AC, which is this side, the one I was calling C, is equal to 10. So AE is 10. And we're done. Now, there's actually a completely alternate way to do this, and I'll show you a way to do it that's even debatably a little bit easier using ratios. Here's what you can do. You notice we never used this DC is 1.5 times the length of BC part. So once we know that BC is 8. Okay, I noticed a slight error on here that this should be in 1 1/4, not 1 1/2, but we can continue from there. So they say DC is 1 1/4, or 1 1/4 times the length of BC. So once we know BC, we just take that 8 and times it by 1 1/4, which is 1.25. So it's 8 times 1.25. 8 times 1.25 is 10. So that means DC is 10. But look at this, 60 degrees. That means these are both 60 degrees. So this triangle is equilateral because it's isosceles, so you know that the remaining 120 is split equally. So it's actually got to have all three angles and therefore all three sides being congruent to each other. So that's why if this is 10, then so is this, and so is this, and therefore so is this. Completely different way of reasoning through it, but gets you to the same answer and doesn't even use the Pythagorean theorem along the way, so they give you a little bit of extra information there.